Today we will talk about discrete probability distributions. The first one I'll cover is the binomial distribution. For an experiment to be binomial, you have to have fixed number of trials. They have to be independent from each other. And outcomes are classified into two categories, as failure and as success. And the probability of success remains the same throughout the experiment. The formula is fairly lengthy. You have n factorial n minus x factorial in the denominator, x factorial, p to the x times q to the n minus x. Each one is defined underneath. N is number of trials, x is number of successes, p is probability of success, and q is the probability of failure. You can pause your video at this point and write this formula down. The first example is I'm tossing a coin 3 times and write down the outcomes. Find the probability of getting exactly 2 heads. In this experiment, n equals 3, x equals 2. This 2 matches that 2. Probability of success, that means probability of getting a head, it's 50%, and getting a tail is 50%. When you plug into the formula, you get these numbers, and you have to multiply them in your calculator to get 0.375. But when you do it in your TI-83 or 84, all you have to do is to go to distribution and scroll down to get to the binomial PDF, which is the A option. Push that. The first number you're going to enter is total number of trials. In this case, it's 3. And then you'll put a comma, and you'll put the probability of success, which is 0.5, and you put a comma, and then how many successes you want, that's the x. You enter 2, close the parentheses, enter, it will give you 0.375, just as you did before. Now let's go to the next example. Let's assume I'm doing the same experiment, and this time I want to find out about getting at most 2 heads. That means 0, 1, or 2 heads. When you plug into the calculator, you'll have to enter all these numbers and add them up to get 0.875. Now, in your calculator, you would have gone and get those binomial PDFs and add them up, but there is another button right underneath the binomial CDF button, which is the cumulative one. In other words, when you push this button, it's going to go and start adding things up from 0, 1, and then whatever that number that you're entering, you will add it to that point. 3, 0.5, so you enter n and p, and here you enter the x. In this case, it's going to be 2, the at most. In other words, it's 0, 1, or 2. When you push enter, you will get 0.875, just as before. The hardest example is getting at least something. In this case, it's at least 2. Same experiment. At least 2 means either you'll get 2 or 3. You add the probabilities. Again, it's pretty lengthy. Instead of doing this, I can use a hybrid approach of binomial CDF button. The getting 2 heads and 3 heads will be the same as 1 minus getting 0, 1 heads just taken out. So in other words, 1 minus binomial CDF 3, 0.5, 1. When you do that, 1 minus, and then go pick out the distribution again. Just scroll down to get binomial CDF, enter 3, 0.5, and what is it that I don't want? Up to 1. And then close your parentheses, and you'll get 0.5 just as before.